Tutorial sheet 1, question 13. We're asked to do a convolution of these two functions, x of t and h of t, as given by this equation. And if we write down the convolution integral in its full form, we get that. Integral from minus infinity to t of x of tau times h of t minus tau d tau. So what we've got to do is, we are given x of t and h of t, we've got to convert them to, first of all, x of tau and h of tau, which is just replacing the variable t with tau, so it looks exactly the same. Then we've got to take h of tau, and first of all, we have to flip the function with respect to the t is equal to 0 axis. So in other words, we're taking that function and we're doing that with it. And then we can shift it to some value t, which goes to minus infinity. And then as t increases, because we need to know the output from minus infinity to plus infinity, so we have our function, we flip it, we shift it, and then we gradually move it across. And we have to look for regions where the function will then overlap with our input function. And then we can carry out this product of the two functions and do the integral. So to tackle a problem like this, we need to split it up into several regions. And the first region is when t is less than or equal to 0. Now, if I draw a graph of this, remember, our dummy variable is now tau. So this is x of tau, and this is h of t minus tau. So this is, because we've shifted it to a negative number, so we've got minus t here and minus t minus 2 because its width is still 2. And there is no region from anywhere from minus infinity to plus infinity where these two functions overlap. So the product is always going to be 0 from minus infinity to plus infinity. So in this case, y of t is equal to 0 for this region. So that's our first important piece of information that we have. Then, as this function moves across and passes over tau is equal to 0, we then have our first non-zero product. And nothing's going to change until we move it across, until the trailing edge of this function passes tau is equal to 0. So the next region of interest is from 0 is less than t is less than or equal to 2. And if we plot a graph of what this looks like, so that's x of tau still. Now our function, which has a leading edge at t, has a trailing edge still of t minus 2. Now the region in which these overlap is between 0 and t. And so the output, y of t, is equal to the integral from 0 to t of the amplitudes of both these functions, which they're both 1, which is equal to t. Again, that's a useful function that we will need later. Again, as this function moves across, the next time something changes is when the trailing edge goes beyond tau is equal to 0. So the next region of interest is when 2 is less than t is less than or equal to 3. If we plot a graph of what that looks like, in this case, our x of t minus tau, sorry, h of t minus tau is completely inside x of tau. So the integral is very simple, it's just the area under this curve. So it has a width of 2 and a height of 1, so the output at that point is just 2. The next region is when t goes beyond 3. In other words, this leading edge comes outside x of tau. So the next region is when 3 is less than t is less than or equal to 5. In other words, the trailing edge is still inside this function. And again, the region of interest is just in this overlapped region. So our output is now the integral t minus 2 to 3 of 1 times 1 d tau, which is t between t minus 2, tau between t and minus 2 and 3. If you work that out, you get 5 minus t. The last region is when the trailing edge is completely outside of the function, which is when t is greater than 5. And in this case, what you get is a function that looks like this. Where x of tau and h of t minus tau don't overlap at all. In that point, y of t goes back to 0 again. So we've got our various elements that we need, so we need to summarize that to say y of t is equal to all the equations that we've just derived. So we've got 0 when t is less than or equal to 0, t 0 is less than t less than or equal to 2, equal to 2, and 2 is less than t is less than or equal to 3, it's equal to 5 minus t in this bit, and 3 is less than t less than or equal to 5, and it's equal to 0, and t is greater than 5. And that is a summary of the convolution we've just carried out.